Hello everyone, this is the brief demo for federated learning using XP devices. The setup comprises of 4 client nodes and 1 server node. We have used Zigbee devices by Digi International, which uses IEEE 802.15.4 for physical layer and media access control. Higher layer protocol stack is developed and maintained by Zigbee Alliance. These devices operate at 2.4 GHz ISM band. These radios can support a maximum of 250 kbps over the 8 data rate. These are short-range devices. We have used these XP devices to enable the transmission of data from one machine to another. This setup enables a real-world implementation of federated learning with over-the-air data transmission. In this demonstration, we will be using an impersonation attack dataset. In this threat model, there is one benign sender Alice and one receiver Bob. These devices communicate using on-off keying mechanism. The adversary Dave listens to the on-off keying based signaling from Alice and then injects energy only when it detects zero energy level. Hence, Bob observes non-zero energy levels all the time. The attacker is successfully able to impersonate as the benign sender. To overcome this, a secret key is pre-shared between the benign sender and the receiver. When the sender has to send bit 1, it chooses an energy level from a set of energy levels using the secret key. Since the attacker has no knowledge of the secret key, he will choose an energy level at random from the same set of energy levels. This creates the difference at the receiver. When the received symbols are plotted at the receiver, the images will look as shown. The points will look more scattered from the adversary compared to the benign sender. This becomes a classification problem at the receiver. This model can be extended with 4 receivers, client 1 to client 4, who receive different data but want to learn from each other without sharing their data. This scenario can be implemented using federated learning, where devices constantly learn about different attack patterns from each other. We start by running the client codes which train the model using its own dataset. We are using a convolutional neural network model that has 7253 parameters with architecture shown on the screen. The clients will only share these parameters with the server. Now we will start the server code, which first scans the network and gets a list of all clients. Server successfully discovered 4 devices. Now the server will send the command to clients for data transmission. Here it sent the command first to client 4. Server started receiving data from client 4. Similarly, server will receive the data from all the clients. Server successfully received all the weight files. Now it will aggregate the weight files using federated averaging. Now the server will start transmitting the updated weights to all the clients one by one. We can see the improvement in accuracy with rounds. Client 1 achieved around 90%, Client 2 achieved around 91%, Client 3 and Client 4 achieved around 92% after 15 rounds. The total time taken for 15 rounds is 75 minutes. Each round took around 5 minutes. We can also observe the per class accuracy increment in this graph. In this way, all the clients can learn from each other and improve their attack detection accuracies.